Hey folks, Ms. Gosling here to discuss a example work problem. So I'm going to go ahead, I'm going to read through the problem, and then I'll show you how to solve. So in this problem, I drag a 5 kilogram object 5 meters across the floor against a frictional force of 7 newtons. I then lift it up 1 meter and carry it 3 meters before putting it on a table. How much work did I do on the object? I'm going to go ahead and I'm going to start by drawing a picture of this situation because I kind of have 3 different parts of my story. So let's go ahead and okay, so what I'm going to do is go ahead and finish my picture. So here is the floor, and that is 5 meters. And here's my 5 kilogram object that's being dragged in this direction. And as it's being dragged, it is feeling a frictional force of 7 newtons. Then it's going to go up 1 meter to here and be carried over 3 more meters to be placed on a table. And as it is being lifted, the other piece of information that's not really in here is it is being lifted against a resistive force, which is of course going to be the force of gravity, which is the weight of the object. So what I'm going to do is I'm going to go ahead, I'm going to figure out the amount of work being done on the object in part A as it's being dragged, in part B as it's being lifted, and finally in part C as it's being carried horizontally. And before I put any numbers, I just want to remind you all of the equation for work, which is that work is equal to force times displacement. So that is going to mean that it is equal to the force that acts on an object, causing a change in its motion in some way. So without further ado, let's go ahead and list out our givens. Okay, so for section A, the force is going to be 7 newtons, and that force is being exerted on our object across a distance of 5 meters. Let's also talk about part B. So in part B, our force is going to equal m times g. It's going to be gravity, which is going to be 5 times 9.8. And here my force is positive because, again, I'm lifting it against the force of gravity. So gravity is down and my applied force is going to be up. I also know that the distance the object travels in section B is 1 meter. And then finally, for section C, I know that the force acting on the object is 0 newtons because there is nothing resisting my moving it from its original position in point C to its final position in point C. And that force of 0 newtons is applied over a distance of 3 meters. And that is going to be all of my givens, which means I can move on to the next step and list out my unknown. And my unknown is my total work. So I'm going to just make that a W, and I'm going to say that is equal to question mark because it is my unknown. Next, the equation I'm going to use and the equation I'm going to use is work equals force times distance, but I need to expand that out a bit because, again, I have 3 different situations that I'm looking at. I'm looking at A, B, and C. So I'm going to say that the work is equal to the force of A times the distance in part A of my story, plus the force applied over part B of my story times the distance over which that force is applied, and finally the force applied over part C times the distance of the object that the object travels in section C. And there you have it. I have my equation written out. Now I can go ahead and move on to the substitution phase. And I'm going to go ahead and plug in all of my numbers. So I have work is equal to the force at A, which is 7, times the displacement at A, which is 5, plus the force at B, which is 5 times 9.8, times the displacement at B, which is going to be 1, plus the force at C, which is 0, times the displacement for section C, which is 3. And now I'm ready for my last step, and that is to go ahead and solve. So what I'm going to do is stick that all in a calculator. You can also do this in your head. It's especially easy to do in your head if you round g to 10. And what I'm going to find is that the total work done on my object is 84 joules. And there you have it, folks. Now you know how to calculate the work done on an object.